Guys, let's do this quickly. So we need to have a short vlogging on the planetary science. Okay, talking about okay the study of the asteroids, the comets, the planets, the sun, the Milky Way, the universe, something like that. So in this topic, we need to mention a lot of, not a lot, I think it's a sort of 4 or 5 scientists like that started with Ptolemy. Okay, Ptolemy discovered that the universe is the center in the all planets, of all the planets. The universe is the center. So he means there geocentric. And after that, the discovery of Copernicus. Okay, that the sun is the center of the universe and the planets revolve around that. It's the reverse of the study of Ptolemy. And then after that, another scientist developed more. It's Johannes Kepler. His study will be more rigid now and with experimental basis. Still the same with Copernicus, but he improved and adds a lot of concepts regarding the semi-axis of the orbit, the radius, the diameter, okay, something like that, and the time interval, okay, like that for those planets to be revolving around the sun, okay. And then this Johannes Kepler have 3 laws of gravitational in the planetary universe. So there are 3, right? So actually the first law of Kepler, first law, is that all the planets are traveling in a circular motion in an ellipse orbit, having the sun at one side at the foci, something like that, okay? So it is the sun, okay, and the planets are revolving in an elliptical orbit, or shall we say oblong, not circle really, okay. And then number 2, these planets are having an adjoining line. If this is the sun, this planet's here and there's a line adjoining them, okay, like that. And then the sun is here, then equal to the area of the sun, something like that. And then and equal also to the time interval. Okay, for example, one revolution in a year, for example, the Earth will rotate to the ellipse orbit entirely 365 days in one equivalent period interval of time, something like that, okay. And the third law will be the most important one because this is the basis of our formula, okay. It says that the time of the orbit, okay, the time interval of the orbit is the square root for that is equal to the cube root of the semi-major axis of the orbit. Okay, if this is the sun and there's a elliptical orbit and there's a semi-major axis between the sun, okay, like this in the orbit, like that, the cube root of that is directly proportional to the time interval, okay, as the planets completely revolve on that ellipse orbit, something like that, okay. So that is time orbit interval, orbit time interval, something like that, in rotating and revolving to one orbit in the universe, something like that, okay. And that's the time we will derive an equation, something like that, okay. But it is understood to be t raised to the power 2, something like that, or shall we say is directly proportional to the r cube root 3. R is the semi-major axis of the orbit and t is the orbital time interval, okay, something like that, okay. Then we can have a new equation in which t raised to the power 2 over r raised to the power 3, something like that, okay. And then it is equal to g times m over 4 pi. The g is the Newton's gravitational force constant, equal to 6.7 times 10 to the negative 11, okay, Newton, okay, meter squared, kilogram squared, something like that, okay. So that's our capital G, and m1 and m2 are the masses of the planets, between planets planets to planets. Okay, or it could be the mass of the sun. It depends on what you are computing to. Okay, because we have the reference of our computation, something like that. And then knowing also the centripetal force, capital F subscript C is equals to mv squared over r, m is the mass, v times velocity raised to the power 2 over r. Okay, and the gravitational force is equals to the Newton's gravitational force constant times the m1 m2, the masses of the planets, over r squared, and the r is the semi-major axis of the orbit, elliptical orbit, something like that. In that we can compute what is the mass of the earth now, providing we have the distance from the reference of the sun to the elliptical orbit that this earth rotating, something like that. Okay, so normally we have the 365 days, so that will be our t. Okay, the time interval of the orbit in equivalent rotation in orbit, 365 days in 1 year, something like that. So we can compute. For example, if there's a question, calculate the mass of the earth, like that, okay, having radius of or distance of away from the sun, then we can compute for the mass of the sun. Okay, but based on the study of Johannes Kepler and combination of the Isaac Newton's gravitational force, the distance of the Earth to the Sun, Earth's orbit to the Sun is 104 times 10 to the power 9 meters, something like that. And the time, capital T interval, is 365 days in 1 year, right? And we can compute for the mass of the Earth, something like that, by having that formula. Thank you so much. God bless everybody.